and welcome to this lesson on Introduction to Networking and IP addresses. In this lesson, we will explore the fundamental concepts of computer networks and delve into the intricacies of IP addresses, which serve as the digital addresses for devices on the Internet. Imagine a bustling city where every house has its own unique address, making it easy for mail to be delivered to the right door. In the digital world, networking works in much the same way, with every device needing an address to communicate efficiently. This is where the concept of IP addressing, Internet Protocol, comes into play, acting as the cornerstone of how devices find each other across local and global networks. So why do we need IP addresses? When devices communicate over a network, whether in a local office, LAN, or across the vast expanse of the Internet, each message needs a destination, just like mail being sent to the right house. However, every device comes with a hardware address known as the MAC, Media Access Control, address, a unique identifier burned into it by the manufacturer. While MAC addresses work well for small, local networks, they become impractical for global communication, as they're scattered randomly around the world. Imagine trying to find a house if addresses weren't organized by country, city, or street. To solve this, the creators of the Internet introduced a more organized addressing system, the IP address. This logical scheme makes it easier for devices to find each other, no matter where they are on the planet. For decades, the Internet has used the IPv4 addressing scheme, which consists of 4 sections that are made up of 8 bits separated by dots. Each 8-bit section is known as a byte. In total, it is made up of 32 bits, which is equal to 4 bytes. Each byte can be converted to a number from 0 to 255, giving us over 4 billion possible combinations. Each IPv4 address is split into 2 key parts. The network identifying component or network ID, which routers use to guide messages closer to their destination. The device identifying component host ID, which pinpoints the specific device within a local network. This organization allows routers to efficiently transfer data across networks, directing packets toward the correct destination. Now let's look at the 2 types of IP address we have. Public IP address. These are addresses visible to the Internet. They are used to identify devices directly connected to the Internet, such as servers, routers, and modems. Private IP address. These are addresses used within a private network, such as a home or office network. They are not visible to the Internet and are used to communicate between devices within the network. Public IP addresses come in 2 varieties. Imagine your home address. If it never changed, your friends and family could always find you. That's the idea behind a static IP address. It's a permanent digital address for your device, making it easy to locate on the Internet. But what if your home address changed every week? It would be difficult for people to find you. That's similar to a dynamic IP address. It's temporary, and your Internet service provider can assign you a new one at any time. This is often used for home Internet connections where a fixed address isn't necessary. Now, imagine a magical address that stays the same no matter where you move. That's the concept of an AWS Elastic IP. It's a public IP address that you can attach to an Amazon EC2 instance, ensuring it always has a consistent Internet address. This is useful because of the following. Consistent access or static connectivity. Applications and services can rely on a fixed IP address for easy connectivity. Enhanced fault tolerance. Downtime can be minimized during an EC2 instance failure through the power of elastic IPs. Load balancing mastery. EIPs can be used to distribute traffic across multiple instances, improving performance and reliability. Granular security group management. you can define fine-grained access rules that consistently apply regardless of the underlying causes of dynamic IP. DNS records management. You can set up DNS records pointing to your EIP, making it easier to remember and access your services. Having explored public IP addresses, let's turn our attention to private IP address classes. Private IP addresses, as we've discussed earlier, are used within private networks to enable communication between devices. These addresses are not visible to the Internet, ensuring a layer of security. To better understand how they work, let's delve deeper into the three main classes of private IP addresses. 1. A Class A private IP address falls within the range of 10.0.0.0 to 10.255.255.255. This class offers the most IP addresses, making it suitable for large networks with many devices. Common use case of this would be with enterprise networks, data centers, and larger organizations. 2. A Class B private IP address falls within the range of 172.16.0.0 to 172.31.255.255. It provides a good balance of IP addresses for medium to large networks. This is commonly used for corporate offices, educational institutions, and mid-sized businesses. 3. A Class C private IP address falls within the range of 192.168.0.0 to 192.168.255.255. It is ideal for smaller networks with fewer devices. It is commonly used for home networks, small businesses, and branch offices. The reason these particular ranges are designated for private use is to prevent conflicts with public IP addresses. These ranges are reserved for internal use and are not routable on the Internet. This helps ensure that devices within a private network can communicate with each other without interfering with public Internet traffic. The choice of private IP address class depends on the size of your network and your anticipated future needs. A larger network might benefit from Class A or Class B, while a smaller network can use Class C. It's also important to consider the possibility of future growth and allocate enough IP addresses to accommodate expansion. By understanding the characteristics of each class, you can make an informed decision about which one is best suited for your specific requirements. Now, despite using private IP addresses internally, devices still need to communicate with the wider Internet. This is where Network Address Translation, NAT, steps in. NAT acts like a translator, mapping private IP addresses to a single public IP address for communication with the outside world. This process allows multiple devices within an organization to share a single public IP address, conserving valuable IP address space. There are two main types of NAT. 1. One-on-one translation. Each device has a unique routable address mapped to it. 2. Many-to-one translation. All devices share a single public address, with the router keeping track of which responses belong to which device using session IDs. Now let's understand what CIDR notations are and how they can help us efficiently manage and allocate IP addresses in our networks. CIDR, which stands for Classless Interdomain Routing, notation is a way of representing a range of IP addresses, known as a CIDR block. When designing a network, the goal is to ensure there are enough IP addresses to meet your needs without making the range excessively large and wasteful. As you may recall from the beginning of this session, IPv4 address is typically written as 4 decimal numbers separated by dots. Each of these numbers is called a byte, representing 8 bits, with values ranging from 0 to 255. When you combine all 4 bytes, you get a 32-bit address, allowing for a total range of 0.0.0.0 to 255.255.255.255. In CIDR notation, this entire range would be written as 0.0.0.0/0, where the number after the slash shows how many bits make up the network mask. That means, when we look at the CIDR block, 10.0.0.0/26, the /26 tells us that 26 bits are being used for the network portion of the address, leaving the remaining bits for the host addresses. So, to find out how many bits are left, we subtract 32 from 26, which equals 6. This means we have 6 bits available for our IP addresses. Next, we calculate the total number of IPs using the formula 2 to the power of 6, which gives us 2 to the power of 6 equals 64 IPs. So, with the CIDR block, 10.0.0.0/26, you have a total of 64 IP addresses available for use within this range. Why does all of this matter, you may ask? It matters because networking and IP addressing are the unsung heroes that make our digital lives possible. From sending emails to streaming videos, this intricate system ensures that every packet of data finds its way from sender to receiver, no matter the distance. It's a remarkable blend of organization, logic, and technology that keeps our interconnected world running smoothly. So, that's all for this session. See you in the next one.